Alright, I think you guys might be able to use another supplemental video on how to make net ionic equations, how to write these equations. So I made a little cheat sheet of, steps, processes to go through while you're doing these. So we'll just kind of follow it as I go through, and I'll post this too. So the first thing you want to do is determine your product. So I'm going to look at a double replacement reaction where we have, AB plus CD goes to AD plus CB. All right, so we're taking the cations, right? A and C are cations because cations are always written first, and then the anions, the negative ones, are written second. So I've got BD. So all I'm doing over here is taking I write my cations down, A and C, and then I switch the anions, B and D. All right, so over here, that would look like I've got barium, got the barium ion, and then I have the chloride ion. So don't bring that 2 over yet. That 2 just came from the barium having a +2 charge. And then I've got sodium ions and I've got carbonate ions over here. And don't bring this 2 over on the other side because that 2 is only there because of the carbonate ion. So on my product side, I'm going to write my cations. I've got barium, and I've got sodium, right? The cations are the positive ones. And then I'm going to switch places. So now the carbonate is going to go with the barium, the chloride ion is going to go with the sodium. Got my carbonate over here, and I've got the chloride ion over there. So all I wanted to do was figure out what my products are, and the first step they say, right, determine your products, and then I'm going to crisscross the charges and make the subscripts, and that's going to give me my formulas. So I'm going to crisscross here. I've got a +2, -2, so that just gives me barium carbonate, and then I've got sodium chloride, just NaCl. All right, so be careful with the polyatomic ions. If you don't have those memorized, here's that list again. And like I was saying before, don't bring over the subscripts unless they are part of the polyatomic ion. So I brought this 3 over because that's part of the carbonate, but I didn't bring this 2 over to the sodium because that 2 is just telling me I have 2 sodium plus ions, and I need 2 of the sodium plus ions because carbonate has a -2 charge, so I have to make this a neutral compound. So I'll find that out when I start balancing. All right, so just going back to these rules, I determine my products, write my cation, anion, I crisscross, make my subscripts. That's my formula. I didn't bring over the subscripts unless they were part of the polyatomic ion, and now I have to balance. Okay, so now I'm going to balance. I've got 1 barium, I've got 1 barium. I've got 2 chlorides, so I'm going to put a 2 in front of here, which also gives me 2 sodiums, which is good because I have 2 sodiums over here. I've got 1 carbonate, 1 carbonate, done, balanced. And you'll know that you skipped that step if you get down and you start canceling things for the net ionic equation and you have like 1 sodium over here and 2 sodiums on the other side. Well, that doesn't make any sense, right? You have to have that balanced. So if you skip that part, you'll realize it later on, and then you can balance later on. You can just go back and balance. Not a big deal. So now we want to figure out, now this is the tricky part. Now you want to figure out, looking at your products, are they soluble ionic compounds? Are they aqueous? Are they solid, liquid, gas? So I'm going to use this table. The liquids and the gases are not in this table. This is just to tell me if I have a soluble ionic compound. So over here, again, this side means these are usually soluble. These are the exceptions. This is what makes this thing not soluble, a solid. So like chlorides are usually soluble, except with silver, lead, and mercury. When I have silver chloride or mercury chloride, lead 2 chloride, then I'm going to have a solid. So these are usually soluble except there. These are usually solids except with these. So the things that are always soluble, there's like an always soluble list. So nitrates and acetates are always soluble. And then these group 1 metal cations. So what are those group 1 metal cations? If I go to the periodic table, you can see these guys. These are always soluble. So whenever you see lithium, sodium, potassium, rubidium, cesium, think those things are going to be soluble. They're going to be aqueous. These are going to end up being my spectator ions. I'm not going to have these in a solid. Those are always soluble. All right, so look for those. Look for those ones. And I can add that list here. Okay, so looking at my products, I've got barium carbonate and I've got sodium chloride. So right away, I just told you about sodium, right? Sodium's on the always soluble list. So this guy is going to be aqueous. Chlorides are usually soluble, except with silver, lead, and mercury, but sodium's not one of the exceptions. So sodium is always soluble. Whenever you see sodium, just make that aqueous. Unless you have sodium metal, which that's in the single replacement reactions, we can look at that. Now barium carbonate, the way you'd use the table would go back, look at the table, and you're looking at carbonate. So carbonates are usually solids, except when you have one of those alkali metals. So if you had sodium, lithium, potassium, those are the alkali metals, that would make it aqueous. or if you had the ammonium ion, that would make it aqueous. So carbonates are usually solids. They're usually insoluble, so it's not going to be aqueous unless you have one of these. Barium is not listed as an exception, so barium carbonate must be a solid. So this is my solid. So on my list of what I'm doing, I figured out, identified what the phase of matter is. Do I have the soluble solution, or do I have a solid, liquid, gas, whatever I have? Great. And now I'm going to identify which ones are strong electrolytes. So the strong electrolytes, those are the ones we're going to give stars. So I'm going to look for strong acids, strong bases, and soluble ionic compounds. So if I have an ionic compound, that's a metal and a nonmetal, or a metal and a group of nonmetals, a cation and an anion, those are ionic compounds. If I have one of those and it's soluble means aqueous, then it's going to dissociate. That means it's a strong electrolyte. When I put it in water, it's going to split up into ions. I also have this list of strong acids. I have it listed here. I have it listed down here too. So any of these are strong acids. Remember, acids have a hydrogen out in front. Usually there's a hydrogen out in front. These are the strong acids. If you get a compound that has a hydrogen out in front, and then it's going to, and it's not on this list, then it's going to be a weak acid, and it's not going to dissociate into ions. Our strong bases are also soluble ionic compounds. So we've got these group 1 metal cations with a hydroxide. And then we have, which again, if you go up here, it says hydroxides are usually solids except when, well, except when you have these group 1 metal cations as well as calcium, strontium, and barium. So they're calcium, strontium, barium. So strong bases are also soluble ionic compounds. So you don't really have to memorize all these yet. You just have to recognize that they are soluble ionic compounds, and then you'll be good to go. All right, so what we're going to do now is identify which ones are strong electrolytes, and then we're going to dissociate them into ions. So this is a soluble ionic compound. He gets a star. This is a soluble ionic compound. It's ionic because it's a metal and a group of a metal and a polyatomic ion. This is a metal and a nonmetal. This is an ionic compound, but it is a solid, so it's not aqueous, it's not soluble. He does not get a star. He's not going to dissociate into ions. He's going to stay exactly how he is when I start writing the complete ionic equation. So what I'm doing now is I'm building up the complete ionic equation, and I'm going to take all of the strong electrolytes and dissociate them into ions so you can see what ions are present in solution. Sodium chloride is also a soluble ionic compound, so that's a strong electrolyte. So anybody with a star now gets split up into ions. So I'm going to have my barium chloride is going to split up into barium ions and 2 chloride ions. 2 because I have this 2 down here. I don't have this ion. This is not a real ion. Cl2 minus, that does not exist. That's not what we're doing here. What I have is barium chloride. I have 1 barium ion, and then I have 2 chloride ions, and chloride has a -1. I need 2 of them because each one has a -1 charge. And if barium has a +2 charge, I need the charges to equal 0. They all have to add up to a neutral compound. That's why I needed 2 there. For my sodium carbonate, similar situation. I've got sodium, I've got 2 sodium ions, and I've got a carbonate. Great, and that's going to give me barium carbonate, which is a solid. And then I've got 2 sodiums and 2 chlorides. That's my complete ionic equation. Now I'm going to cancel things that are exactly the same on both sides. Sorry, let me go back, follow our rules, right? So I identified all the strong electrolytes, and then to complete we dissociated the strong electrolytes. We split them up into ions. If you have a weak acid, keep it together. If you have a solid, keep it together. Or a liquid or a gas, keep it together. Don't dissociate those. Don't turn them into ions. They're not ions. They're staying solid. They're staying liquid. They're staying together. They don't split up into ions because they're either weak or non-electrolytes. The last thing we're going to do is we're going to cancel things that are the same on both sides. So I'm going to cancel my chloride ions, my sodium ions. And this is the part where you'll recognize if you forgot to balance. Because if I didn't balance this over here, I would have 2 sodiums and then 1 sodium over here and 1 chloride over there. So that should indicate to you that, like, wait, these are not balanced. Of course they have to balance. So those are my spectator ions. Spectator ions are the things that just watch the reaction go by. They're not involved in the reaction itself. So then I can finally write my barium plus my carbonate aqueous with the barium carbonate. So this is the net ionic equation, right? That's when they say write the balanced net ionic equation. This other one, that's your complete or total ionic equation, and the first one's your molecular equation because everything is, there's no charges in this first one. Do you see how I wrote this on top, but then there's no charges there. This next one has charges on everything except for the solid, right? Because I split everything up into ions, but this guy doesn't get split up, so don't give him any charges. And then the last thing I have, I've got my charges on these ions. You need to show those because this is your net ionic. Ionic means you have ions. Ions are charged particles. And then my solid doesn't have any charges, so that's going to be solid.